Hello Math 8 students, this is Utah Middle School Math Project 1.1 C and E, where we're solving equations that include multiple steps like simplifying before we can even solve it. So to get started, we have a warm-up where we're doing exactly what I just described we're going to be doing in the lesson. We have an equation, which is an expression equal to another expression, but the right-hand expression, the expression on the right-hand side of that equal sign, needs to be simplified before we can start solving this equation. And so I need to combine my like terms. I have 3 x tiles and I have 8 negative x tiles. When I combine those, that's going to be 5 negative x tiles. Just like I need to combine these units. I have 2 positive units and 6 negative units. We're going to have some 0 pairs, and that's going to leave me with 4 negative unit tiles, or negative 5x minus 4. All of that is still equal to 71. So understand that the first step that I took was just simplifying the side of the equation that needed to be simplified. And now this looks like the same equations that we were able to solve last year in 7th grade, just 2 steps. I'm going to undo subtracting 4 by adding 4. Balance it by doing the same thing to the other side. And I get 71 plus 4 is 75, and that is equal to a negative 5x. When I need to get x alone, I see that it's multiplied by a negative 5, so I undo multiplying by a negative 5 by dividing by a negative 5, and again keeping it balanced, doing the same thing to the other side. That leaves me with x, which is equal to 75 divided by negative 5. Use your calculators if you need to. Go ahead, Luis. Negative 15. And in your calculator, as you're entering this quick poll, I do want to see it entered like this. Don't just say it's negative 15. Tell me that x is the thing that is negative 15. That's that Math Practice 6, Attend to Precision. So I'm going to pause the recording now as students in class talk about the mistakes. We only had about half of the students in class get this correct. So talk with your mistakes talk about your mistakes with the people at your table, and we'll continue on with 1.1 C and E. Ready, set, go. Okay, in 1.1 C, in our last video, we realized that an equation is really truly just an expression equal to an expression. And with that, it makes it easy to understand why sometimes we're going to see equations where one side is really busy, has a lot going on, and why we need to take those steps to simplify it. When we do that, though, we're going to realize that the equations simplify down to something that's very easily managed. Just a 2-step equation for these linear equations. And so we've got some practice now. Picking up where we left off in last video, we have some equations that we need to solve, but in every single one of these equations, we need to simplify them first. In a group that was maybe struggling a little bit more, I would encourage you to model each one of these. These are all small enough that they can be modeled, but I think this group that is hearing this video, you guys are probably ready to not model. Is that a correct assumption for you guys? So let's just get to simplifying. One of the things that I would like to point out, you guys know that I'm a big fan of flow maps, right? Why is a flow map not going to work for a problem like number 4? Talk with your groups about that first. Take a look at 4. Why is a flow map not going to work? Quick conversation at your table. Ready, set, go. Okay, who would like to share with the recording now? Why is a flow map not going to work? Let's start with Liv. Yeah, x is in 2 different places. And so when I say what's happening to x, you'd say, well, which one, right? But if I take this step to combine like terms, 4x and 3 more x, combine to make 7x, now if I still needed that structure of a flow map, now x is in only one place, so it's easy to say what's happening to x. Oh, you're talking this one because there is only one. So take the time on each of these to simplify first. Because this first set is fairly intuitive, I'm going to pause the recording and let students work on them. When the recording continues, all of the work, including the answers, will be there. So only continue on past this point if you're ready to see the answers. Pause the recording now. Okay, and those are the answers put up there by the students. Great opportunity to check your answers. Any questions now that you've seen them? Okay, Yeah, it should be easy. It should just be a combination of the two things we've been practicing up to this point. We know how to simplify expressions. We know how to solve equations. So now we're combining both of those practices into one single problem. So we've got some more to practice here, 8 through 13. Again, only move on past this point in the video if you're ready to see the answers, because the next time you see the screen, it will have all of the answers. Pausing the recording now. All right, and here's all the answers. Again, with work shown by students, you can check your answers, check the steps that they took to get there. And now we're ready to move on to some stories. So the first couple stories, there's got a lot of structure in them, so that we can kind of see the different steps that they are taking to write their equations. Carson and his family drove to Disneyland. They started driving on Thursday and then stopped for the night. On Friday, they drove twice as many miles as they had on Thursday. On Saturday, they drove 50 more miles than they had on Friday. Carson's mom, being the mean math teacher mom that she is, made him do some math and says, write an equation to determine how many miles they drove each day. Sounds like a math teacher mom thing to do. So match each expression that we see here with what it represents in the story. So you'll draw lines like M. If we reread the story, we might be able to figure out what M is. And then we see that M is multiplied by 2. So what does that represent in the story? Take a few seconds and let's get that sorted out with your tables now. I'm going to pause the recording to give some think time, and then we'll come back together. All right, what does the M represent? Where am I going to draw this line to? Bella. Yeah, they drove some miles on Thursday, which means that the 2M is going to represent what, Luke? Number of miles driven on Friday. Because as it says, on Friday they drove twice as many as they had on Thursday. Okay, and 2M plus 50, Leroya, the number of miles driven on Saturday. On Saturday they drove 50 more miles than they had on Friday. Remember, 2M is Friday's total, and plus 50 is 50 more than that, which means by process of elimination, the total number of miles driven is going to be when I add up each one of those pieces. So now let's turn that into an expression, or excuse me, let's turn this total miles expression into an equation. If Carson and his family live 650 miles from Disneyland, how many miles did Carson's family drive each day? We know that adding up all of the miles all together is going to be equal to the grand total. So these are balanced. It's an equation that's balanced. And now that that's ready to go, we can solve and figure out, okay, how much did they drive Thursday, Friday, and Saturday? First step is figuring out what is M equal to. So we're going to combine our like terms. M plus 2M plus 2 more M is 5M. Plus the extra 50 is equal to 650. And now we've turned this into just a two-step equation where I can subtract 50 from each side and get 5M is equal to 600, which I then am going to divide each side by 5 to figure out that M is equal to, yes, thank you, Trace. Fantastic, 120. So what does that mean? Let's go back. What does M represent? M is the number of miles driven Thursday. So on Thursday, that's 120 miles. Friday is 2 M's. 2 times 120 would be 240 miles. And Saturday, miles driven on Saturday is what they drove on Friday plus an extra 50, so 290 miles. Okay, so that one was very structured for you. This next one is also very structured, but pay attention to what we're doing here because the next one is going to be, I'm going to loosen the reins just a little bit. So again, part of a story that matches the expressions is shown, the expressions shown has a story that matches, but there's some parts that are missing. So I have these bits and pieces here and parts of a story. Let's see if we can look for those connections and complete the story. Theo is training for a triathlon. That makes sense because I see minutes swimming, minutes running, minutes biking. So it makes sense that he's training for a triathlon if he's doing all of those activities. He runs twice as long as he swims. So let's take a look at that. Here's running, and that's 2x. because the amount spent swimming is just X. So this would be twice as long running than he bikes. He bikes, and then it's blank. How much does he bike? Put it in a story. Check in with your groups first. How can we put that into words, and what are we going to write down here? So again, we're looking at how much he bikes. How can we relate it to the other things that he's doing? Who would like to give it a try? Let's try Emily. Yeah, so if we wanted to go all the way back to swimming, we could say he bikes twice as much as he swims plus an extra 30 minutes more. You're absolutely right. But since we already have a relationship between swimming and something that's happening twice as much, we can make it even simpler by relating it that way. Luis, what would you say? Yeah, he bikes 30 more minutes than he runs. Exactly. He bikes 30 more. He bikes 30 more minutes than he runs. Let's see what else we have. He swims 3 times a week. So let's start looking for a connection there. Remember, he spends X minutes swimming, and now it's saying he swims 3 times a week. Where am I seeing that information? Ooh, found it. Luke, where are you seeing that? Yeah. Yeah, great. Good. So again, swimming is X, and we're seeing 3 times X here. So he swims 3 times a week. Let's keep on reading. He runs 4 times a week. Remember, this is how much he runs, 2X. Where am I seeing that he does that 4 times a week? Leroya. Yeah, here's the 2X, and that 2X is happening 4 times. And lastly, and he bikes, fill in the blank. Remember, this is how much time he spends biking, the 2X plus 30. Where am I going to figure out how much he bikes? Davin. Twice a week. Yeah, outside of the parentheses, there's a 2 showing this biking amount is happening 2 times. So he bikes twice a week. Finishing up the story there. Okay, so the structure that it gave us was a little bit different, but again, we're making connections to representing things mathematically, even though it's a real life situation. And so now we can continue. If he spends a total of 510 minutes per week training, how many minutes does he spend on each exercise at a time? So here's all of those things added together. That's a total of 510 minutes. And again, it's just an equation to solve. It's an equation that requires simplifying this piece first. So let's do that. 3x plus 4 groups of 2x means I have what so far? Yes. Let's just go slower. So we have 3x here. Let's simplify this part. What's 4 groups of 2x? 8x. And now let's simplify this. 2 groups of 2x is 4x, and 2 groups of 30 is 60. So now, altogether, how many x's do I have? 15. Combining all of those like terms, I have 15x plus 60 is equal to 510. Subtracting 60 from each side. And I get 15x is equal to 450. Divide each side by 15. And I have x is equal to, which part now? 450 divided by 15, what did you get there, Oren? 30. And so again, what does that x represent? Minutes spent swimming is 30. Minutes spent running is twice that, 60. And minutes spent biking is 30 more than that, so that would be 90. Okay, unfortunately, we didn't make it to finishing up this last one. We definitely need to go over this one, so we're going to save this for next time. In the meantime, though, your homework is let's do 1 through 9. I want us to do more. I want there to be practice with the error analysis. But for right now, I'm happy if you guys just do 1 through 9. Fair? Okay, time to get cleaned up. That's it for today. Thanks for watching. We'll see you next time.